my name is Edana Ramirez, and this is the Introduction to Reference Angles. So let's first begin with the basics. So first, we're going to start by learning the formulas. So let's begin. So the first formula begins with drawing a graph, or your x and y coordinates. And this formula will be for quadrant number 2, which is located here. So what you do is you get your reference angle. So I like to begin by drawing the reference angle. I think that it helps by making it in a different color, just to help identify it. And always remember to put the sign of the reference angle in the middle. So after we do that, we learn the formulas. So the first formula is to find reference angle equals pi minus the original angle. And that is defined for radians. And the second one is reference angle equals 180 degrees minus the original angle. And that is what you find for degrees. So then after that, we move on to our second formula. Again, you draw your x and y coordinates. Remember, it does not have to be perfect. And here again, I like to draw it in a different color. Let me just make that bigger so you can see it better. So I like to draw it in a different color. So here is where we move on to quadrant number 3. And the way I like to remember the formula for quadrant number 3 is it's basically the formula for quadrant number 2, but flipped. So here we're going to put reference angle equals the original angle minus pi for radians, and then the reference angle equals original angle minus 180 degrees. Again, remember to put the reference angle in the middle. So that's for quadrant 3. And finally, we move on to the last formula, which is for quadrant number 4. Draw the x and y coordinates, then you draw your reference angle, and here, it's going to be located here. So quadrant number 4. The formula for this one is similar to the one for quadrant number 2, however, it is a little bit different. So the formula for radians is reference angle equals 2 pi minus the original angle, and then that's for radians, and then you do reference angle equals 360 degrees minus the original angle, 4 degrees, as you can see here. The reason for that is that you can see that it does almost a full circle here. Moving back into quadrant number 3, you can see that it's closest to 180 degrees, and then finally for quadrant number 2, you can see the small section there. It is important to know this so you can be able to identify the location of the specific angle that it's giving you, and then you can locate it on the unit circle, which will be helpful for the problems.
Now, since we've learned the basics to the formulas to find the reference angle, now we're going to do 2 easy problems to find the reference angle. So let's first begin with the first problem. So it gives us 210 degrees. So how do we find that? So first, we're going to draw the x and y coordinates for the graph. And you're going to want to be able to locate 210 degrees on this graph. So approximately, it would be around here in the 3rd quadrant. We know this because 210 passes the 180 degrees line, so we can see that it's in quadrant number 3. So if we look back into the formulas that we just learned, we'll see that the formula to find degrees for the reference angle is the original angle minus 180 degrees. So let's go back into the problem. So now, since we know the formula that we have to memorize, we do 210 degrees minus 180 degrees. Here we can use the calculator, and we'll find that the answer is 30 degrees. And as simple as that, you find the reference angle for degrees for 210 degrees. Sorry. Now let's move on to the second problem. So again, you're going to want to put your x and y coordinates. But as you can see here, it's not in degrees. So what do? This means that you have to use the formula to find radians. So if you remember the unit circle, you know that this part is pi over 2, and then this is 3 pi over 2. There. Keeping that in mind, we can remember by looking back into our unit circle that 5 pi over 4 will be located also around the 3rd quadrant, which is perfect, which is what we just last used. So we're going to put quadrant number 3 and fix that. Again, we're going to look back into our formulas that were given, which is in blue, as you can see. So to find the radians for quadrant number 3, we do the original, or what was given, which was 5 pi over 4, subtracted by pi. As you can see, it does not have the same denominator. So what we have to do is we have to multiply pi multiplied by 4 so we can get the same denominator on the top and the bottom. So the answer to that would be, you put the original 5 pi over 4 minus 4 pi over 4. So then that would equal 1 over 4 pi, which is the reference angle for this problem. And that's it. That's how you find the reference angle, by using the introduction given and the formulas.
Now, do a real world application. Actually, it's one of the best foods in the world.
This pepperoni pizza. Let's use our imagination. I have invited you to my house and 10 other people. In total, we are 12 people in my house. And you are the math whiz in my house, and you want to find out how big is the slice. You want to find out the angle of the slice. Well, luckily, you can find the angle of the pizza by using the reference angle formulas Edana had mentioned in the beginning of the video. But you were mad when you got to my house because you don't like pepperoni pizza. You only like cheese pizza. So, you wanted the one that's literally only cheese, and that is this one right here.
So you want to find out how big is the slice, the only cheese slice. So if you remember your unit circle, this slice would be, well, remember it's not perfect, it would be an angle 150. And so remember the formula, 150 is closest to 180. 180. And so by using the formula of the reference angle, you can find out how big is your slice and how many degrees is the slice. So remember the formula, 180 degrees minus 150, and this will give you how big your slice is. 30 degrees. Your pizza slice is 30 degrees. So I will be giving some more. So here it tells us, evaluate the trigonomic function. It gives us cosine 7 pi over 6. So how do we find the reference angle of cosine 7 pi over 6? So in order to find this, we must locate this on the unit circle. This is right about here. Right about there. And we have to find the reference angle, this reference angle right in there. 7 pi over 6. And you have to recall the formulas Edana had mentioned. So since this is 180 and it's closest to 180, you subtract 180 from this original angle. And so 180 in radians is pi. But wait, they have to have the same denominator in order to be subtracted. So you multiply you multiply 6 in order to have the same denominator. So times 6 on the top, and now you could subtract 6. 7 pi minus 6 pi is pi. And now you have the reference angle. But the question is asking, evaluate the trigonomic function. So you are going to be using the reference angle in order to evaluate the trigonomic function. Pi over 6 is the first one on the unit circle. And you have to remember the coordinates. Remember the unit circle. Here are the coordinates of pi over 6 on top right there. And if you recall, we are trying to find cosine. We need to find the reference angle, so it would be the opposite. And remember, the minus indicates direction. So minus negative right here is cosine, because remember, cosine is x. So it'd be negative square root 3 over 2. And that's how you use the reference angle in order to evaluate the trigonomic function.